Hello, welcome to Mr. AP. I am Mr. R and I will be going over the 2024 AP Precalc free response questions. Okay, let's begin. So this first FRQ, it is a calculator FRQ. So it's A1 is asking for h of 3. So A1 is asking for h of 3 and h of 3 is equal to, well, h is equal to g of f of x. So we have to do g of f of 3. And f of 3, we can look at this graph here. F of 3 is equal to 1. So we have to do g of 1. And we are given this function right here. G of 1 is equal to 2.041. So h of 3 is equal to 2.041. Okay, A2. It's asking for all values of x for which f of x is equal to 1, f of x is equal to 1 on the graph of that. So that is this. So it's basically asking for what values of x intersect that line. That happens when x is equal to -3, x is equal to 0, and x is equal to 3. So you would write f of x is equal to 1 when x is equal to -3, x is equal to 0, and x is equal to 3. Okay, B part 1. All values of x as decimal approximations for which g of x is equal to 2. So for this question, we have to plug it into our calculator. So we plug in the g of x function, and then we do y equals 2, and then we use our graphing calculator to find where it intersects, and that would be at 1.057. So g of x is equal to 2 when x is equal to 1.057. And remember, College Board wants you to always round to 3 decimal places, so make sure you are doing that. No more than 3, no less than 3. Okay, B part 2. Determine the end behavior of g of x. So if we look at the function g, it is a exponential function, so ab to the x, and we can see that the b value is less than 1, and if the b value is less than 1, then the graph will be an exponential decay function, so it's going to look something like that. So as x goes to infinity, g of x or y just approaches 0. So mathematical notation of a limit, you would write lim as x approaches infinity. Oh, my stylus died. Give me a second. So lim as x approaches infinity, g of x is equal to 0. That is your answer. B part 2. Okay, so C part 1. Determine if f has an inverse function. Okay, so f does not have an inverse function. Yeah, so it does not have an inverse function. C part 2, I'm gonna type this out. So C part 2, give a reason for your answer based on the definition. So f does not have an inverse function, and as the definition of a function of the graph. So because if you were to invert f, there would be multiple output values for a single input value, and the definition of a function is that each input value has only one output value. So like, what's the saying? Oh, 1-to-1. It would be 1-to-1. So yes, that is C part 2. Okay, FRQ2, this is also a calculator question. So A1 is just asking you to write two equations. This is a very basic question. It's just asking you to use the values that are given to you at the very top here and make an equation. So G of T, okay, so the number of units sold are already in thousands. So you would not, so it says 40,000 here, so you would not plug in like 40,000 into the equation, you would just plug in 40, okay? So we just plug in the numbers that are given to us. So so G of T is equal to A plus B ln T plus 1. That is the function G. So we just plug in 40, which is G of T, is equal to A plus B ln, and we're given that T is equal to 0 when it's at 40. So 0 plus 1. Again, we're just writing two equations that will help us find the A and B value. You don't have to derive any equations for this first part. And the second equation would be 76 is equal to A plus B ln, and it's at 76 when the T value is 91, so we do 91 plus 1. And then in A part 2 is when we solve for the A and B constants. So for this question, you have to know that ln of 1 is equal to 0. And in this first equation, we see that ln is 0 plus 1, ln 1, that's equal to 0. So it would cancel out b, leaving you with just a is equal to 40. So we already have that constant. A is equal to 40. Now we plug that into our second equation so that we can find our b value. So 76 is equal to 40 plus b ln 91 plus 1, which is 92. So 36 divided by ln of 92 is equal to your b value. So b is equal to, let's see, b is equal to 7.961. Again, you have to do 3 decimal places. Unless it's just some whole number like 40, you don't have to put your 3 decimal places. So that is your b value. Now b part 1. B1. Use the given data to find the average rate of change. So that's just y2 minus y1 over x2 minus x1. Your y values are your units that are sold. So it would be y2, 76 minus 40. Again, this is just given at the very top right here, divided by 91 over minus 0, which is 36 over 91, which is 36 over 91 is 0.396. That is your average rate of change with the data that is given to you. Use the average rate of change. Okay. B part 2. Average rate of change found in the previous question to estimate the number of units. So for that one, you just plug it in. So y would be equal to your average rate of change, 0.396, multiplied by your t value, which is 50, and then add your constant, 40, your a value, and that will give you your average rate of change, and that is equal to 59.8. Okay. Now B part 3. Let A of t represent the estimate of the number of units. So for using the average rate of change. Okay. Found in T. Explain more. Okay, so for this question, B part 3. So your average rate of change is always, your average rate of change is just your slope, and your slope is linear, okay? And then g of t, the function given to you, is a logarithm. So if we were to graph it, it's not accurate, but it would look something like that. That would be your function g, and then your slope or your average rate of change would look something like that. So let me write that in a different color. So this would be your average rate of change. Okay. Okay. And explain why in general A of t is less than G of t between 0 and 91. So let's say this is like 0, and then this part right here is 91. Okay. So it's asking why A is less. So based on your graph that is given to you, or the graph that we just drew, so we can see that your logarithm function, it's concave down, and because of that your average rate of change would underestimate your actual graph. So your actual graph G is overestimating your average rate of change you found, so A is underestimating, which is why A is less than G of t between 0 and 91. And then for part C, the makers of the video game decrease. Explain why the error. Okay, we can see it right here. If we were to continue drawing this, and we can see that the error, or they're getting farther and farther away each other. The error is increasing. This is because A of t is linear. It's a positive linear. So it continuously increases. And then your model G is concave down, so it decreases. It continuously decreases. So as one increases and the other decreases, after t is equal to 91, it would just, the error between each other would start to get farther and farther apart, so the error increases. Okay, next FRQ. The next two FRQs are no calculator FRQs. Okay, we have a tire with a radius of 9 inches. So we know that this distance is 9. So this would be 9 inches. This would be 0 inches, and then you add another 9. That would be 18 inches. A person rolls the tire. So we have point W right here. And then it touches the ground at half a second. So at 0.5, it is on the ground. And then it completes a full rotation at 5/2. So if you do 5/2 minus 1/2, that's equal to 2. So it takes 2 seconds for one rotation. So your period is equal to 2. Okay. So again, it says that it touches the ground, which is this, your J. It is at 0 when it is at 1. The time is at 1/2. So at time 0.5 or 1/2, the height is 0. And then the period is 2 seconds, so it would go back another 0.5. So if we were to go back, we have to go back, change in 0.5. So this would become 0, and then it would be at the middle, which is 9. And then it would go back another 0.5. So it would be negative 0.5, comma 18, since it's at the top. And then we go forward 0.5, so it would be at 1, comma 9, so at the middle. And then another 1.5 would be at 1.5, comma 18. And the period is 2, and if we take the absolute value of 0.5 plus 1.5, you would get 2, which is your entire period. That is your period, 1 period. Now we have to write an equation. So h of t is equal to, so using A, B, C, D. So A is your amplitude. Your amplitude is the distance from the midline, and it goes up 9, it goes down 9. So your amplitude is 9, but if you look at the graph that we made, the points that we plotted, 0, 9, and then it starts to go downwards. A sine wave that starts to go downwards, that means that it's negative. So the a value is not positive 9, it is negative 9 sine. And then your b value is equal to 2 pi over your period. 2 pi over your period. If we go back up here, we saw that our period is 2 seconds. So b is equal to 2 pi divided by 2, which is just equal to pi, since those cancel out. So you would replace b with pi. Then t is just your constant, so you can just put t. And then c is your phase shift. But if you look at this graph, there actually is no phase shift, since the 0, 9 starts at the correct place at 0 seconds. So this would just be plus 0. And then your d value is your midline. Your midline, if you look back here, is at 9. So your d is 9, so you do plus 9. And there is your equation. Okay, let's continue. Refer to the graph of h in part A, the t coordinate k. So k is t1 and p is t2. K is t1 and p is t2. So this is t1, this is t2, so we're analyzing this part of the graph. And it's asking which is true. So it's positive, decreasing, positive, negative. Okay. So our y values are always positive since it's from 0 to 18 feet. So it's always positive. It's not going like below the ground. So we can cancel out the ones that say negative. And then now we have to see if it's increasing or decreasing. And the y value is going from 9 to 18. So it is increasing. So the answer is A. And then the next one asks how the rate of change of h is changing on the interval t1, t2. So it's asking for the rate of change. So the rate of change is just referring to your concavity. So if you look at this interval, t1 to t2, it is concave down right now. Right here, it is concave down. And if it is concave down, that means your average, or the change in your rate of change is decreasing. So you would say, let me type this up. And that is your answer. It can be worded a bit better, but yeah. So because it's concave down on that interval, the rate of change is decreasing. There is your answer. Okay, on to the fourth FRQ. This is also a no calculator FRQ. Okay. A1. It's asking g of x is equal to e to the power of x plus 3, and it's saying to solve for g of x is equal to 10. So we do e to the x plus 3 is equal to 10. To get rid of e, we have to do the natural log. So we natural log both sides, ln 10. That would cancel out ln and e, and that would bring the exponent down. So we just left with x plus 3 is equal to ln 10, and we are solving for x, so ln is equal to ln 10 minus 3. That is your answer. Okay. A part 2, arc sine of x over 2, solve for pi over 4. So arc sine, that is just your inverse sine. Same thing. Arc sine x over 2 is equal to pi over 4. So if we want to cancel out arc sine, we just have to take the sine. So sine arc sine x over 2. Whatever we do to one side, we have to do to the other. Okay, sine of pi. Okay, so this cancels out. and that leaves us with x over 2 is equal to the sine of pi over 4. We draw a circle real quick. The sine of pi over 4 is here, and that is where it is root 2 over 2, root 2 over 2. So x over 2 is equal to root 2 over 2. You multiply both sides by 2 to get x by itself, and you get root 2. Yep, you get root 2 is equal to x. You're done. Next question. Okay, so we must rewrite j of x as a single logarithm without negative exponents. Single logarithm, so this is what it should look like. Okay. b1 is log 10. Let me just write this out real quick. Okay, when you are adding logs, that's the same thing as multiplying, and then when you're subtracting, that is the same thing as dividing, and then when you have something in the front of a log, that is your exponent, so you have to bring it over. So 9 log x would just become x to the power of 9, since that is your exponent. Okay, let's simplify this. So log 10 is equal to 8x to the 5th. Again, you're just multiplying these two since you're adding them, and then you're dividing x to the 9th since you are subtracting that log. Let's simplify this further. So you multiply the coefficients and then you add the exponents. So 8 times 2 is 16, and then 5 plus 2 is x to the 7th. You keep over x to the 9th, and then when you're dividing exponents, that is the same thing as subtracting. So you are left with 16 over x squared. That is your final answer. So it didn't really say to simplify, so if you left your answer like this or even like this, you probably still will get the points for it, so don't worry about that. Okay, let's go to B2. B part 2. Rewrite, okay, this is the trig identity problem, so rewrite k of x involving only tangent of x. Let's write it over here, 1 minus sine squared x over sine x secant x. So the first thing that you want to recognize with this is that 1 minus sine squared x is equal to cosine squared x. So you derive that by doing cosine squared plus sine squared is equal to 1. This should be the trig identity that you always remember. And if you just do minus sine squared from both sides, you're left with cosine squared is equal to 1 minus sine squared, which is that. So now you plug in cosine squared x back in over sine x, and then secant x is equal to 1 over cosine x. So that would cancel this cosine x, and that would cancel out the other cosine x. So you're left with cosine x is over sine x is equal to tangent, or it's equal to cotangent x. But again, the question asked rewrite k of x as a single term involving tan x. And tan x is just equal to the reciprocal of cotan x. So it's just 1 over tan x, and that is your final answer. The last part, part C, inverse cosine tan 2x, that yields an output value of 0, so you set that equal to 0. So C is equal to is equal to 0. The cosine of 0, 0 is right here, the cosine of the coordinates is that, so the cosine, which is the x, is 1. So tan 2x, oh, my stylus died again, give me a second. So tan 2x is equal to 1, and then that happens over here. which is pi over 4. So we just do the inverse tangent and inverse tan of 1, which is pi over 4. You're left with 2x is equal to pi over 4. If we look back at the question, it wants it for all values in the domain. So you have to do, since the period of tangent is pi, you do plus pi k, where k is an element of an integer. So you get all the values, but we want just x, so we have to divide everything by 2. And the final answer is x is equal to pi over 8 plus pi over 2 k, where k is an element of an integer. That is your final answer. And I believe we are done. Okay. And we are done. Thank you.